Hi everyone, hope everyone's well. We are going to be now working on the second part of surds. Okay, so last lesson the last thing we went through was how to expand surds when they were in brackets. I'd like you to do that now or apply that to the following question. And if you could just pause your screens now so that you can try that question and then we'll go through it, okay? Okay guys, well done. Let's just get this set up for us. All right, lovely. Hopefully that focuses. There we go, perfect. Right, so in this question, we have a rectangle, and they're asking us first to find the area of both rectangles, okay? So let's take a look at part 1. If we want to find the area of this, we're going to take 11 plus root 2, and we have to multiply it by 5 minus root 2 because it's a rectangle, length times width, to get the area. Now that we're going to expand, so 11 times 5 is 55. 11 times negative root 2 is minus 11 root 2. Root 2 times 5 is plus 5 root 2. And root 2 times negative root 2 is minus root 2 root 2. Okay, so let's simplify what we can. So we've got 55, negative 11 root 2 plus 5 root 2 would be minus 6 root 2. And finally, minus root 2 times root 2 would be just minus 2, because remember, you get the number inside the surd when you multiply them by itself. And that means we can simplify this bit, so we would get 53 minus 6 root 2. Now, in the question, they didn't tell us what the units were, so we could put it in a bracket, and we could say units squared, because they didn't actually specify that, okay? Right, let's look at part 2. This time, it's a square. All right, so they're telling us that we have a side length of 2 plus root 8, so we're going to have to multiply that by another 2 plus root 8. Okay, you can simplify root 8, so I would suggest that you do that first, so let's do that. So that's going to be 2 plus root 4 root 2, and another 2 plus root 4 root 2. Okay, and that means we're actually multiplying 2 plus 2 root 2 times another 2 plus 2 root 2. So let's do that. 2 times 2 is 4. 2 times 2 root 2 is plus 4 root 2. 2 root 2 times 2 is plus another 4 root 2. And then 2 root 2 times 2 root 2, the 2's multiplied together gives us 4, and then root 2 root 2. Okay, now at this stage we have 4 plus 8 root 2 when we bring these together, plus now we know root 2 times root 2 becomes 2, so 4 times 2 will give us 8. So our final answer, we're going to bring those together, that's going to be 12 plus 8 root 2. And its area, we don't know the units, so we can say units squared. Okay. In both of these cases, the areas would be irrational, and that's because of these surds. Okay, once we add or take them away from these normal numbers, that turns them into irrational numbers. And I'm just mentioning that because that should help us with part B a little bit, just in terms of the concept. Part B says, would the perimeter of each shape be rational or irrational? Explain. Well, I think it might depend on the shape. If we look at part I, we would have 5 minus root 2 plus another 5 minus another root 2 plus 11 plus root 2 plus the other 11 plus root 2. Now, if we take a look at that, negative root 2 will cancel with one of those. That will cancel with one of those. And so actually we have 5 plus 5 plus 11 plus 11. So that's 10 plus 22, which is 32. And we don't know what the unit is, so we'll just put units. Okay, that's obviously rational. Okay, there isn't a surd there. All right. But if we look at part 2, let's take a look. We would have 2 plus root 8, and there are 4 of them, so I'm going to put that in front to make that easier. And that's going to be 8 plus 4 root 8, which we know is going to become 8 plus 4 times root 4 root 2, which is 8 plus 4 times 2 root 2, okay, which gives us a final answer of 8 plus 8 root 2. Again, because that root 2 is irrational, even adding it to the whole number of the 8, even multiplying it by an 8, and then adding it to the whole number of 8, it's still going to be irrational. And that's because of the surd. Okay, and that's how we would explain it. We would then write a sentence stating that due to the surd here being added to the normal number, it causes it to become irrational. And in this case, it's just a whole number, and therefore it's rational. Right. So we're going to move on to looking at rationalizing a denominator. I'm going to make this full screen because I would like you to take notes on this. You can pause the video as we go. Oops, not that one. I want that one to be full screen. Hold on. Apologies. I want that one. There we go. Okay. So, as I said, you can pause and take notes as we go, but we are going to be looking into more detail of rationalizing the denominator. So that can be your mini title. Okay. And we're going to look at different types of examples. Okay, so last time we did this, I taught you things like this. So 1 over root 5. I don't want a root 5 on the bottom. We know that we can multiply by another root 5 to turn it into a 5. We have to make sure we do the same to the numerator as we do to the denominator. Okay, and so that obviously gives me root 5 over 5. Lovely. Right, and that's rationalized. It's now a rational number in the denominator. Okay, so that was the type of example we did last time. I took you a little bit further, and I said that we could have an example like this, where maybe we had 2 over 3 root 2, okay? So in this case, I'm not going to multiply by 3 root 2. I only need to worry about the surd and rationalizing it. So I'll make it easier for myself, and I multiply by root 2. Okay, same in the numerator, and that would give me 2 root 2 in the numerator over 3 root 2 root 2, which would give me 2 root 2 over 3 times 2, because that becomes 2, which is 6. Okay, now remember, I do cancel where I can, and so my final answer in this case would be root 2 over 3. So we did extend you further last time, and we looked at this type as well. Okay. The other thing that we taught you to do was to expand, okay, which we have done a few examples now, but let's just look at one more just to make sure we remember before we move to the next step. So this isn't rationalizing. This is just so that we can move to the next step of rationalizing, okay? So let's say I had 3 plus root 2, and I multiplied it by 3 minus root 2. Okay, we would do 3 times 3, which is 9. Then 3 times minus root 2, minus 3 root 2, and then root 2 times 3 plus 3 root 2, and then root 2 times minus root 2, which is minus root 2 root 2. Okay, so that is going to give us, we know this becomes a 2. 9 take away 2 is 7. Okay, and then these actually cancel out. I'm actually just left with 7. Okay. All right, so that's an interesting one, and that's actually going to become important in a moment, because what you'll notice is by multiplying this by the 3 minus root 2, the 3 and the root 2 are the same, but I changed the sign. You should remember difference of squares, where we had a 0x term. So this relates to when we did difference of squares. So x plus 3, x minus 3, you might remember, gave us x squared plus 3x minus 3x. Minus 9, which gave us x squared minus 9, and this bit canceled out. We're actually applying that concept to surds so that we can eventually rationalize a denominator with more than one thing. So let's take this and actually turn it into a rationalization question. So example 4 now, we're going to have 2 over, let's say 4 plus root 6. And I need to rationalize that. So the question would actually ask me to rationalize the denominator. Right. So let's take a look at how we do that. Okay, let's follow our example here. If we had 3 plus 2, then we multiply by 3 minus 2. So we're going to do the same thing here, but let's just put that in a bracket to remind ourselves. I'm going to multiply by 4 minus root 6. Okay, you have to change the sign. It has to be the opposite sign or this does not work. And then on the top, times the same thing because it's a fraction. Okay, we want to retain the value and keep it the same. So now let's expand this. 2 times 4 is 8. 2 times minus root 6 is minus 2 root 6. And that is all over 4 times 4, which is 16. 4 times minus root 6 is minus 4 root 6. Root 6 times 4 is plus 4 root 6. And then root 6 times minus root 6 is minus root 6 root 6. Okay? Right, so now we can start to simplify. Those cancel out, which is what we wanted. Okay, 8 minus 2 root 6, let's keep that the same at the moment. All over. Now 16, take away root 6 times root 6, which is 6. So 16 take away 6 is 10. Okay, we're not completely done yet because we do need to divide out a 2 because everything divides by 2. So that would make a 4, a 1, and a 5. So my final answer is 4 minus root 6 over 5. Done. Okay, so we will go through the rules again later just to remind you. But when I have 2 terms in my bottom expression, I need to make sure that I multiply by the same thing but change the sign. And what that will do is that will eliminate the surd. As we can see here, the surds will cancel out. Okay, so that's kind of the input I need you to have. We're going to start with a few easier questions where we don't have all of that in our denominator. Okay, and then we'll move to questions where we do. All right, so let's move you back to the questions. And I would like you to first try these. So pause your screen now and then press play when you're ready to go through the answers with me. Okay, lovely. So they've done the first one for you. Okay, or mostly. They've actually given you part of the answer, so let's take a look. So 11a, we started with 3 plus root 2 over root 2. Okay, now we know to rationalize, we have to multiply by root 2, so that's what we can write down. Okay, now I don't like time signs. In this example, they've given you time signs. You don't really need that, so we write this as 3 root 2, like I've been doing, okay, and then plus root 2, and that is all over root 2 times root 2, okay, that gives us 3 root 2 plus 2 over 2, all right, and we're done. So they've given you those steps, but obviously I think you're now at the stage where you don't need to have those time signs. You can just write them together because you know that that means times. Right, so part B, we have 6 minus root 3 over root 3. We're going to multiply by root 3, and we're going to multiply by root 3 here. Okay, so I'm now comfortable. You've done many examples. I'm happy for you to now miss this middle step where you're writing this bit, okay? So for a simple question like this, you don't need to do that. 6 times root 3 we know is 6 root 3. Minus root 3 times root 3 we know is minus 3. And root 3 times root 3 is 3. Okay, we do have to simplify. That becomes a 2, a 1, and a 1, which means my final answer is 2 root 3 minus 1. Okay, well done. Let's take a look at part C. We had 19 minus root 7 over root 7. Okay, multiplying by the root 7 because that's in the denominator. And we're going to get 19 root 7. Okay, minus root 7 times root 7 is minus 7 all over 7. 19 is a prime number, so is 7. I can't cancel down, so we're done. Okay, And finally, part D. We have 5 plus root 5 over root 5. Okay, we're going to multiply by the root 5. And that's going to give us 5 times root 5. And then plus root 5 times root 5 is 5. All over root 5 times root 5, which is 5. They all cancel and become 1s. And so we are left with root 5 plus 1. Final answer. Okay, so well done on those. And now I want you to apply that knowledge to this question here, which is a past paper question. All right, so press pause, have a go, and let's see if we get 3 marks. Okay, well done. Let's see how we did. So let's write it down. We have 8 minus root 18 all over root 2. And they want us to write it in the format of a plus b root 2. Fine, so we know we need to rationalize, in other words, so we multiply by root 2, top and bottom. Okay, that is going to give us 8 root 2. And then minus root 18 times root 2. We need to use the rule where we multiply those and put it under the same root sign. So it's going to be minus, and 18 times 2 is 36, so minus root 36. And that is all over root 2 times root 2, which is 2. Right, so we can now continue. We have 8 root 2 minus 6, because the square root of 36 is 6, all over 2. These are going to cancel down. That's going to become a 1, a 4, and a 3, because we can divide out the 2, and which means our final answer. And I want to have it in the correct format. So I'm going to write the negative 3 first. And then I'm going to write it as plus 4 root 2. So your third mark is actually putting it in the correct order. Okay? Kind of get 1 mark here, 1 mark here, and then your third mark is to make sure it matches. And that means our integer a is negative 3, and our integer b is the 4. Okay? I did give you a bit of a hint with the root 2. It helps you realize that you're correct. All right, so make sure you do look at those hints so that you know that you're on the right track. Okay, so that's really good. Well done. Okay, I need you to move on to these questions, or this question, which has multiple parts. Okay, so press pause, and then we'll go through the answer. Right, well done, guys. Let's see how we did. Okay, so let's start with 13a. It says expand and simplify. Okay, we can do that. 3 plus root 5 and 3 minus root 5. Right, so 3 times 3 is 9. 3 times minus root 5. Root 5 times 3. And then root 5 times minus root 5 is going to be minus 5. Okay, those cancel out, and 9 take away 5 is 4. So we're left with 4. Part B says, is your answer rational or irrational? Oh, well, it's a whole number, so it's rational. Part C says, how can you tell if your answer will be rational or irrational? Well, if there's a surd present, it will be irrational. If the surd cancels out, it won't be irrational, it'll be rational. Okay, so if a surd will still be present, the answer will be irrational. Okay, right. Part D. Which of these will have rational answers when expanded? Okay, well, let's have a think. So we have, they want us to actually check by expanding the brackets. Let's have a guess, though. Okay, so if we look at the first one, I would say it's going to be irrational, because I'm going to have a negative 7 root 2 and a 2 root 2, and then they're going to cancel it. If we look at the second one, part 2, they're both positive, so they're going to add together, so they're not going to cancel out. So actually it's part 3 that I think will be rational, because they'll cancel out. but they want us to check, so let's have a go. All right, so 7 plus root 2 and 2 minus root 2. 7 times 2 is 14, and then minus the 7 root 2 plus the 2 root 2, and then minus 2. Okay, so as expected, we're still going to have a surd. So 14 minus 2 is 12, and then bring these two together, and we get minus 5 root 2, and that means it is definitely irrational because that surd is present. Okay, just like we had said. Let's take a look at the next one. So we have 7 plus root 2, and then 7 plus root 2 again. All right, so that's going to be 49 plus 7 root 2 plus another 7 root 2 plus 2, which gives us 51 plus 14 root 2. Again, we have a surd, so it's irrational. Okay, and as we've learned, the next one should cancel out. Let's just double check. 7 minus root 2, 7 plus root 2, and 7 minus root 2. Not that the order matters. So 7 times 7 is 49. 7 times minus root 2 is minus 7 root 2, and then root 2 times 7 plus 7 root 2, and then minus the 2. Cancels, and we get 49, take away 2, which would give us 47 as our final answer, and that is rational. However, we had enough background knowledge that we could tell that without actually calculating it, but we have now checked. So it then makes us apply this to part E, where it says to rationalize the denominator. Okay, so this is what I introduced to you in the input part of the lesson. So let's take a look. Hopefully you got it. If not to worry, now you will. All right, and since we have this in the denominator, we need to multiply by the same thing, but we make it negative because that's a positive. And remember, that's going to cancel out our surd. So let's do that. On the top, 1 times both of those gives me 7 minus root 2. Oops, sorry. Yep. Okay. And then 7 times 7 is 49. And then we have plus the 7 root 2 minus the 7 root 2. And then root 2 times root 2, we get minus 2. Okay. Those cancel out, and that will give me 7 minus root 2 all over 47. Final answer. Okay, and in the denominator we have a rational number, so we know that it's rationalized. Okay. All right, can you take a moment? I'm going to make this full screen for you. I want you to pause, and I want you to add those two rules to your notes. Okay, let me just explain first. We had this when there was a number in front of the surd, and I just want to remind you through this that we only have to worry about rationalizing that surd. So I wouldn't multiply by a root b, just by the surd, the root b. Okay? To rationalize it when there's a fraction, okay, if it's minus here, we have to use a plus. And if it's plus, we have to use a minus. So that was me telling you to use the opposite sign, but to keep these two bits the same. Okay, so take a moment, write those into your notes. Those are the general rules, and then we will move on to the last few questions. Okay, well done. All right, I'd like you to do these now that you've learned how to rationalize those denominators. There's a hint for part A to help you get started, but then after that you should be fine, okay? Okay, guys, well done. Let's take a look. Okay, so in 14a, we started with 1 over 1 plus root 2. Okay, we now need to multiply by the opposite. Please remember that you're going to want to put that in a bracket to make it easier when you expand. 1 minus root 2 and 1 minus root 2. Okay, so 1 times all of that will be 1 minus root 2 over 1 times 1 is 1. 1 times minus root 2. Root 2 times 1. And then finally, root 2 times negative root 2 is minus 2. So we get 1 minus root 2. Remember, those cancel out. So 1, take away the 2, gives me negative 1. Now, we don't like to have the negative 1 on the bottom, so we're actually going to divide the top 2 by the negative 1. Plus, it's not necessary to have that there. When I do that, I'm going to get negative 1, so 1 divided by negative 1, and then the negative root 2 divided by negative 1 will be plus root 2. Okay, and we can leave that as our final answer. All right, that's perfectly fine. Let's take a look at part B. So we have 1 over 5 minus root 3. Okay, so we're going to change the sign. So we're multiplying by 5 plus root 3, top and bottom. All right, that's going to be 5 plus root 3 on the top over 5 times 5, and then plus 5 root 3 minus 5 root 3. You should start getting the pattern now. Okay, it should become a little bit easier. Right, and that's going to be 5 plus root 3. Those cancel out, so we're over 25 minus 3, which is 22. So final answer, because you can't cancel. Okay, so for part C, okay, we put that in a bracket. We're multiplying by the 4 plus root 5. That's going to give us 28 plus 7 root 5 all over 4 times 4, 16, plus 4 root 5 minus 4 root 5, and then minus root 5 times root 5, which is 5. That becomes 28 plus 7 root 5 all over 16 minus 5, which is 11. Final answer. Part D, we have 4 over 1 plus root 6. Okay, so we're multiplying by, 1 minus root 6. Change the sign like we're meant to. So that's going to be 4 minus 4 root 6 all over 1 plus 1 times root 6 is just root 6, minus 1 times root 6 minus root 6, and then minus 6. Which gives us 4 minus 4 root 6 all over. Those go away, and we're left with negative 5. Okay, you can leave the negative on the bottom. Again, it's not usually what we do. We usually move it to the top when we can. So let's do that. If I do that, I get negative 4, okay, plus 4 root 6 over 5. So just change the signs on the top because I'm dividing by a negative. All right, and that's my final answer. I can't cancel that down. Okay, so part E, we had root 5 over 1 minus root 5. Okay, so don't forget, change the sign. 1 plus root 5, 1 plus root 5. Okay, that's going to be root 5 plus root 5 times 5, which is 5, all over 1 times 1, which is 1, plus root 5, minus root 5, and then minus root 5 times root 5, which is minus 5. Okay, that's going to give me root 5 plus 5 all over negative 4. Again, let's move that to the top. So that's going to give me negative root 5 minus 5 over 4. Okay, it's just better practice not to have a negative in the denominator. Okay, last one. And then we'll move on to our last question for the lesson. You've done really well so far. Okay, so let's take a look at F. So we have 6 plus root 2 over 8 minus root 2. Okay, so opposite sign than the denominator, so that's multiplying by 8 plus root 2. And same with the top, 8 plus root 2. Okay, this time we've got 2 sets of double brackets, so I'm going to put that in a bracket. 6 times 8 is 48. Okay, 6 times plus root 2 is plus 6 root 2. Root 2 times 8 is plus 8 root 2. And root 2 times root 2 is plus 2. And that is all over 8 times 8, which is 64, plus the 8 root 2 minus the 8 root 2. So hopefully you're getting good at that. You can spot that pattern, and then minus the 2. Okay. 48 plus 2 is 50. Okay. And 6 plus 8 gives me 14 root 2. Oops. And that is all over, those cancel out. So 64 minus 2 is 62. Okay, and they do divide at least by 2, so let's have a go. That's going to become a 25, a 7, and a 31. All right, so that's all we'll be able to do. 25 plus 7 root 2 over 31. And that's because there's a book prime. There's nothing I can divide out further. Okay, that is excellent. Well done. Right, so I want you to try one more question for today, please. Okay, let's make that full screen for you. Right, pause, try the question, and press play when you're ready to go through it. Okay, well done, guys. Hopefully that was okay. Let's take a look. Ooh, that's weird. Hold on. Okay, that's being a pain. Let's try that again. That's better. Okay, thank you. Sorry. Right, so 15a, we have x squared minus 6x plus 1 equals 0. And they say solve this by using the quadratic formula. So let's remind you of the quadratic formula. Okay, that states that x will be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Please remember that there is a 1 there. Okay, so this means that a is equal to 1, b is equal to negative 6, and c is equal to 1. Okay, so that's a, that's b, that's c. Right, so now we can put them in. So x is going to be equal to negative of negative 6, which is positive 6, plus or minus the square root of negative 6 squared minus 4 times 1 times 1, all over 2 times 1. Okay, so x will be 6 plus or minus the square root of 36 minus 4, all over 2. That's going to be x is equal to 6 plus or minus the square root of 32 over 2. Okay, so we are now going to have to come up with both of our solutions. So let's split this up. Actually, before we split this up, let's see if we can simplify that, because we can. Apologies. So x equals 6 plus or minus, that becomes root 16 root 2 all over 2, which gives us x is equal to 6 plus or minus 4 root 2 over 2. And finally, we can divide out the 2, and that is going to give us x is equal to 3 plus or minus 2 root 2 when we cancel that out. Okay, right, now I can say that therefore x is equal to 3 plus 2 root 2, or x is equal to 3 minus 2 root 2, and those are our two solutions. So that's part A done. Please don't worry if you'd forgotten that. Now we've gone through, I need you to go and relearn it. Right, so part B says solve the equation by completing the square. Okay, let's go to a new page. Right, so we have x squared plus 10x plus 13 is equal to 0. So let's complete the square. Remember, we cut this in half, so we have x plus 5, okay, squared. We have to take away this extra bit, so minus 5 squared, okay, and then plus the 13 that was already there is all equal to 0. We get x plus 5 squared, and then minus 25 plus 13 equals 0. X plus 5 squared And then minus 25 plus 13 is minus 12 equals 0. Now, in order to solve, we have to start rearranging. In case we're going to add the 12 first to both sides. So that's going to give me x plus 5 squared equals 12. Now I can take the square root of the 12. And so we get x plus 5, is equal to plus or minus, don't forget because the square root can be plus or minus, the 12. Then we can move over the 5, so we'd get x equals negative 5, minus 5, minus 5. So negative 5 plus or minus the square root of 12. Now that we know how to simplify that surd, we need to remember to do that. So negative 5 plus or minus root 4 root 3, which will give me x is equal to negative 5 plus or minus 2 root 3. At this stage, I can state my two solutions. So therefore, x is equal to negative 5 plus 2 root 3, or x is equal to negative 5 minus 2 root 3. Okay? So that sorts that one out. Now, let's move on to part C, which says solve that equation. Now, it looks to me like you can use whatever method you'd like. Okay, I'm going to say factorize. So for part C, we have x squared minus 16x plus 8 is equal to 0. Let's factorize that. Okay, two numbers that multiply to a positive 8 but add to a negative 16. Can we? Not looking overly promising, is it? So we may not be able to factorize. That's slightly frustrating. Okay, so next step is actually to write it out. And that's exactly what you do in an exam when you realize you couldn't do it this way and you make a choice. Okay? Between the two, using the quadratic formula or completing the square, it's up to you. You can do either. Okay? I'm going to complete the square because that's what I prefer, but you could do either. So x squared minus 16x plus 8 is equal to 0. I'm going to cut that in half. X minus 8 squared. I'm going to take away that 8 squared, the square of that number. Okay, and then we're going to add the 8, and that is equal to 0. We then have x minus 8 squared minus 64 plus the 8 equals 0. A little bit of simplifying. Minus 64 plus 8 is going to be minus 56. Okay, and then we have x minus 8 squared is equal to 56. We add the 56. Then we take the square root. Don't forget it's plus or minus. Okay, at this stage we can now add the 8. So we get x is equal to 8 plus or minus root 56. Right, can I simplify a root 56? Well, let's have a think. I know I can take out a 4. Definitely, because I can do 8 times 7, so I could do 4 times 14. Yeah, that would work. Okay, so let's do that. So we're going to have x is equal to 8 plus or minus root 4 root 14. And then we're going to have x is equal to 8 plus or minus, simplify that to 2 root 14. Is there anything else I could take out? Well, not really, because 7's a prime number, so it doesn't have a square root. 2 times 7, it's just not going to work, so I think we're stuck now. So it's fine, so therefore we can say that x equals 8 plus 2 root 14, or x is equal to 8 minus 2 root 14. Right, I'm super proud of you. I think you worked really hard on that one. It's quite an intense lesson, okay? But excellent, excellent work. And please go back, play it again, and try those questions again, and really make sure you get really good at them, okay? Because that will help carry you forward. You need to remember this stuff like you remember your name, okay? So go through it again, and that would be lovely. And once again, really proud of you. Excellent work today.